Alright, so next we turn our attention to adding negative numbers, such as -4 plus -5. The good thing is we already have a lot of ingredients here. We have all of our axioms that we learned the first couple weeks, and we've been acquiring a bunch of little theorems. Theorems are packages of these axioms. Each of them we have proven with great carefulness, and we made sure every one of these was completely proven, obeying only the axioms. That takes us to today, where we will try to see how we can use these to add something like -4 plus -5. So we're burning daylight. Let's get to it. It would go something like this. There's many ways of doing it. You can develop your own way. You already have all the rules, and you have your 3.5 pound brain. That's all you need. But if you need a little inspiration, here's an idea. -4 plus -5. That's what's given, and I can rearrange that into something like this. -1 times 4 plus -1 times 5. Right? And the reason I can do that is because of the minus theorem. The minus theorem says I could take these negative numbers and unglue the negativeness from them, such as this. And now I look at that and I think, whoa, it looks like someone distributed a -1. Somebody's been distributing things around here. Look, maybe we could undistribute it. So if we undistribute it, it would look like this: 4 plus 5 with the negative outside. It's easy to check to see if that's a legit step. You would distribute it back in there and you'd see you'd get the previous line. So clearly this is justified by no more no less than the distributive law. We're going to get a lot of mileage out of this, because this is how you add like terms. The idea of adding like terms, I'm adding negatives and negatives, those are like terms, goes a long way into polynomials and a bunch of other things, and at the end, the heart of it will be the distributive law. You'll see, this is powerful stuff. So then I have -1. I know how to add these because that's addition table. Those are natural numbers, and the addition table helps me add natural numbers. Of course, now I can glue back the negativeness into it, or I said differently, I can multiply by -1 easily to -9. Again, that's the minus theorem, and yippee-ki-yay. That's right there is a proof of how -4 of why -4 and -5 is equal to -9, using only axioms and theorems we've proven. We can package all this into one theorem called the negative plus negative theorem, which explains how we add two negative pieces. It says that two negative pieces will give you a larger negative piece. Or said differently, if you read it backwards, it says that a big negative piece could be broken down into little negative pieces. You can read it forwards or backwards. The negative plus negative theorem. Negative a plus negative b is just negative a plus b. And often, if these are natural numbers, you can go one step further if you want, using the addition table. Okay, let's see how you might use this in an actual problem. Just for fun, we could try something like this. Suppose you wanted to add -8 plus 5. Just for fun, suppose you wanted to add that. And you didn't just want to add it. You don't care about the answer. You care about perfect, beautiful reasoning. If all I cared about was the answer, I just put it in a calculator. And there's no shortage of calculators and phones that can do that very easily. But suppose I'm after something else. I'm after powerful thinking, deep thinking, the kind of stuff that will make me the life of the party. Here's what we could do. I'll give you two different options, okay? One using nothing but axioms, or mostly axioms, and see how it goes. -8. What's the definition of -8? -8 was born to be the 8 killer. So if I had 8, I could kill it, but I don't have 5. I don't have 8, I have 5. So the one legal thing that I can always do is add 0, and I haven't changed it. That's the additive identity. And then I can write 0 in a very clever way, so that I can get 8 here. I write it as 3 plus -3. That's the added inverses. That's brilliant. Look, 0, same thing as 3 plus -3. But then look what I'm going to do. I'm going to group these ones. Once I group them, I'll kill that -8 over here, and we'll be left with just the answer, -3. Watch how this will work. -8 plus, I can slide the parentheses. This is called the sliding the parentheses axiom, also known as Associative Law of Addition. These two I can put together. That's -8 plus 8 plus -3. That's addition table. I can focus all my attention on the first two. That's very legal, according to Associative Law of Addition. Says, hey, You can associate whatever, if you have 3 items, you can associate any pair you want that's next to each other. Associative law of addition. Negative 8 plus positive 8, of course, is 0 because those are additive inverses, and yippee-ki-yay. Told you. This is by additive identity. That's beautiful. Perfect step, perfect reasoning. Nothing but the axioms. Oh, that's so nice. And just to inspire you some more, here's a different look at it. Negative 8 plus 5. That's given. Now I'm going to use the previous theorem I had. That would be this one, the negative plus negative theorem, that says that 2 small negative pieces give you a bigger one, or if you read it backwards, it says that a big one gives you 2 small ones. So I'm going to use that here. Instead of having a negative 8, I'm going to break that up as negative 3 and negative 5. A big negative piece broken down to 2 negative pieces. Why? Negative plus negative theorem says I could do that. There's always 2 questions, whether something is legal and whether something is helpful. Sometimes things are legal but not helpful, and vice versa. You want to find things that are both legal and helpful. So this tells you why it's legal. It's legal by the negative plus negative theorem. Why is it helpful? Well, it's helpful because if you just think about 2 steps ahead, what's going to happen is I'm going to slide the parentheses over, and we're going to focus all our attention on the 5 and negative 5. They're going to be killed, and boom, you'll have the answer in a couple steps. It's beautiful. It goes like this. Negative 5 plus positive 5. I slide the parentheses over there. That's called Associative Law of Addition. These 2 kill each other. That gave you 0. Those are additive inverses. 0 plus anything leaves you with that same thing. Just 3. Additive identity. Boom. Same answer. Different way. Using the power of the negative plus negative theorem. Very, very nice stuff. We're getting to show off a little how powerful the axioms are in figuring out what you can and can't do, and in cooking up your own theorems, your own packages of steps that are repeatable. Alright, I think we'll stop here for now. We'll see you guys here next time. Peace.